Hey guys, Mr. Wood back for another lesson here in the middle of chapter 4, jokes. What is a pirate's favorite country? Pirate's favorite country? Argentina. I thought that was a good one. What kind of jokes did Einstein make? Wise cracks, Einstein. Okay, today we're going to get back. We're actually going to pre-lab the lab I talked about in class, in our last class, and the lab we're going to do on Wednesday, Thursday. So kind of giving you the chemistry of this. We're definitely getting to the place now where we're going into stuff that is new stuff. And so again, I'm hoping you guys are following along. I'm not sure y'all are, and I got to tell you how important it is to do it, but it's really up to you to do it. So here is where we are in the notes. So this is online, and this is a pre-lab for the lab. This is the kind of lab. There'll be a question. This is what the lab is about, and there'll be a question like this on that test. So I'm just going to put up the whole slide here. So like I talked about in class, and you saw that we had a mixture that was made up of barium chloride dihydrate and sodium phosphate for 12 dodecahydrate. And a student, just like you are, so this is just like the lab, weighs 1 gram of the mixture and they add distilled water. That's exactly what you're going to do. What is the precipitate? And this is what you're going to do in class on Wednesday and Thursday. You're going to mix it, you're going to heat it, and then we're going to take the filter paper, we're going to put it in the oven, and we're going to let it sit over the weekend so it dries out. We get rid of the water. But then you're going to do that test on that last step in the lab. PPT is precipitate. The precipitate is filtered, washed, dried, and weighs 0.48. That's what we'll do next week. That's what we'll do on Monday, Tuesday. We're going to weigh the filter paper, and we'll just subtract the mass of the filter paper. So they're saying that the precipitate, the solid, weighs 0.48 grams. The supernatant, the liquid that passes through the filter paper, is then divided. This, where it says the supernatant, this is what you're going to do in the lab on Wednesday, Thursday. The last thing is divided into 2 beakers. To one beaker, BaCl2 is added. To the other, Na3PO4 is added. The solution in the beaker that has the BaCl2 added forms a precipitate. The other remains clear. Okay, determine the percent by mass of each salt in the mixture. Okay, so this is, if this makes sense. So what we're doing here is we've got a mixture of, we're going to take through the filter paper. I'm sure you guys can see this. So we're going to have the funnel and the filter paper on it. And you're going to take the funnel down into a beaker. And we're going to collect, this is called the supernatant. Okay, so through here. And on here is going to be the PPT, the precipitate, which this problem said was 0.48 grams. But then we're going to take the supernatant and we're going to split it into 2 different test tubes. So we'll have a little bit in here. In this test tube, we're going to put in BaCl2. And then in this test tube, we're going to put in sodium phosphate, and these are solutions. Okay, and what it said that the solution in the beaker that has the BaCl2 forms a precipitate. So over here now, a PPT forms. So that is a huge clue. And this you got to think about. Again, we had no problem like this in first year chem. So we knew in this solution through here, we know that if we're taking BaCl2 plus Na3PO4, now the waters are going to be part of the problem. In the end, I'll talk about that. But we've got barium chloride, dihydrate, but the hydrate the water I'm not going to represent in the equation because the water is just going to dissolve into the solution. And then I've got the sodium phosphate, dodecahydrate. But again, the water is just going to dissociate in there. So I'm going to take barium The outers and the inners, so I'm going to get barium phosphate. This is a 2 and this is a 3. And then I'm going to do the inners, and I'll get off NaCl. And we know from the solubility rules, we know that this is going to be aqueous. So this is the solid. We know that. And then if I go back and I balance this equation, what I'm going to get is a 3 and a 2 and a 6. Okay, and this is exactly the same equation you're going to have in the lab. So we knew that the barium phosphate was the precipitate. Okay, so the precipitate is the barium phosphate. That's the solid. So that's what's going to be on the filter paper, and that is what we're going to weigh on Monday, Tuesday. But we know in the supernatant, we've got sodium ions and chloride ions in here. But the question is, and that's why we do this test, is was there barium ions in here or was there phosphate ions? One or the other. One ran out, either the barium or the phosphate. So again, in here, I'll make this a little bit bigger. So in here, we knew we had sodium and we knew we had chlorine. And if a precipitate formed, there must have been phosphate. It's kind of hard to read that. That's phosphate. Over here again, I had sodium, I had chlorine, and I was checking that there was barium. And here, there was no reaction. Okay, so this clue, where we added barium chloride, a precipitate formed, that told me, try and write that a little clearer, that told me that there must have been phosphate in there. So the phosphate, then, what this clue told me is the phosphate must have been in excess, because when we added the barium chloride to the solution, a precipitate formed. But here, when we added the sodium phosphate, nothing happened. We didn't get that reaction. So here, that told me that the barium was limited, was the LR. So that was the whole thing about the clue. So when the question is, what is the precipitate? The answer to that is the barium phosphate. Okay, and then it says, determine the percent by mass of each substance in the mixture. So hopefully that makes sense, and I'm more than happy to answer questions on that in our next class. Okay, so now to figure out the percent of what we've got left over. So I'm going to erase this, these. Okay, so now we know that we have 0.48 grams of this. That's what the problem said. We had 0.48 grams of the precipitate. Let me make sure I'm right about that. And because we know that this is limiting, we know that the barium chloride is limiting from this test down here, I'm going to convert, I'm going to do stoichiometry, and I'm going to go back like this. So it's going to look like this. I'm going to take 0.48 grams of sodium phosphate. Because if you're following along, you could ask a real good question. You could go, wait, why aren't you converting to sodium phosphate? Well, I'm not converting to sodium phosphate because the phosphate was in excess. It didn't run out first. The barium was limiting. So I know that it was completely consumed. Okay, so I'm going to start making sure you guys can see this. So now I'm going to do some stoichiometry. So I'm going to go from 0.48 grams of barium phosphate, and I want to convert it back to barium chloride. So in doing this, the molar mass of the barium phosphate is 601.9 grams. For every 1 mole. So now I'm just doing stoichiometry, and now I can use the ratio, which is 1 to 3. So I have 1 mole of Ba3PO4, 2 for every 3 moles of BaCl2. Okay, and then finally, what I'm going to do is I'm going to convert this into grams of BaCl2. And this is the only place in this problem where I've got to factor in the 2 hydrates. The same thing could happen in the lab. It's the only place where I don't ignore that mass. So the mass of this is 244.3 grams. Okay, and if I do that, what I get is 0.58 grams of the BaCl2.2H2Os. Okay. And then go back to the question is, determine the percent by mass. Well, since we have 1 gram, so if I have 0.58 grams, so this is the percent of the BaCl2, 0.58 grams of the BaCl2, and there was 1 gram total. That was the total mixture. So it's 58% then BaCl2. And if there's only 2 parts in it, then I would take 100 minus 58 is 42% sodium phosphate. Okay, and that's definitely it's a good problem, and it's one to look at. And this is what we're going to do in the lab, in our next lab. And so go over that. And again, I always want to encourage you guys to ask questions when you come across a problem like that. So I'll review that real quick on Wednesday, Thursday, but that is the lab. Okay, so now we're going to keep going here. Okay. Sorry, I'm getting messed up. My technology problems. Okay, so here we go. And here again, these are problems now, or problems like we did not do in first year chem. Okay, so this acid-base reactions, right, the molecular, complete, and net ionic for each of the following. Okay, so I want to do these, or at least get through as many of these as we can here today. Okay, so I'm going to go back to the board. And again, first year chem, we always, did the outers and the inners and acid-base reactions. Always was water and a salt, and that's still kind of the case, but we always said there was 2 spectator ions, and that's not going to be the case every time. Okay, so the first reaction we've got, and again, we're doing the molecular, the complete ionic, and the net ionic. So the first one is HCl plus NaOH. This is a review. This is definitely one we did in first year chem. So acid H, base OH, so I do the outers, I do the inners. And remember we said in an acid-base reaction, you always get off water and a salt. And it's not necessarily always going to be like that. Strong acid, strong base, it will. So this, and then I balance it. So this is the molecular equation. So that is done, outers and the inners. Okay, the complete ionic equation. So aqueous, aqueous. On this side, water is a liquid, and this is aqueous because it's got sodium, one of those 4 ions in it. Okay, the complete ionic, I'm going to take everything that's aqueous and I'm going to dissociate it. So I've got hydrogen and chloride. And I've got sodium and hydroxide. So slow down here. The water I don't dissociate though. It's like a precipitate, and then the sodium chloride again. I'm going to dissociate that. Okay, and then the net ionic, I'm going to cancel out the spectator ions, which in this case are the ions that are in the salt. And so what that leaves me is this. Okay, so there is A. And we said acid-base reaction, you always get off in your net ionic, H plus OH gives you H2O. Okay, and that's really, we should say that's when you have a strong acid, strong base. Okay, letter B. So letter B, I've got HCl, a strong acid, plus NH3, a weak base. And this is kind of, ammonia is like the most commonly used in our problems, the most commonly used weak base. So what happens here is the acid is going to give up an H, and it's going to go here. So we're going to get NH4. This one's definitely a little bit different. And we have Cl negative. So the acid acting as an acid. This, we did not do a problem like this in first year chem. Over here to the ammonia. This is the base, and one of the definitions of a base is to be a proton or an H acceptor. So that's what happened here, and it leaves Cl. So this then would be the molecular equation. Okay, the complete ionic equation, again, and what I dissociate, something I don't think I made a big enough point of, what I dissociate are the strong electrolytes. So the strong acids, the strong bases, the soluble salts. So what I dissociate, like up here, that's what I did. Strong acid, strong base, soluble salt. So what I dissociate are the strong electrolytes. So here, I would have H plus Cl minus. That's a strong acid, so I dissociate it. But NH3 is a weak base, so I don't dissociate it. And these two are just ions, so they are not going to dissociate. So the only thing that I dissociated here, and that's again strong acid, strong base, soluble salt, was the strong acid. And so now in the net ionic equation, I cancel out the spectator ions. And like I said, in first year chem, we always said that you always had two spectator ions. It's going to be different in our class. In this case, I only have one, and that's Cl. So this is the net ionic equation. So what is reacting here is the H plus is reacting with the NH3 to make NH4. Okay, so that again, that's a new problem. We did not do one like that in first year chem. Okay, the next one. So here's C. So C, I'm going to take H. Here's going to be the molecular equation. M for molecular. Here's acetic acid. This is not one of the strong acids. With sodium hydroxide, strong base. So here I'm going to do the outers and the inners. Really the only time with this I'm not going to do the outers and the inners when it's an acid base is if I have a weak base. If I have a weak base, I'm not going to do the outers and the inners. And then I'll do the inners, and that will be NaC2H3O2. Okay, and that is balanced. So I just took the H with the OH to give me water. This is liquid. This is aqueous. These are aqueous. Balanced. So the inners were sodium with acetate. Okay, now the complete ionic. Again, what I dissociate is strong acid, strong base, soluble salt. So this is not one of those. This is a weak acid, so it's not going to dissociate. So I do not break it apart. But here, this is going to break down like this. So sodium and hydroxide. And the reason I'm going to do that is because that is a strong base. So it's going to break apart. Water, a non-ionic compound, so it's not going to break apart. But this is a soluble salt. It's got sodium, one of those 4 ions in it, so it's going to dissociate, meaning it's going to break apart. So it's going to be sodium plus acetate. Okay, and so now I cancel out the spectator ions. Again, in first year chem, there was always 2. Here, there's only 1, and that is the sodium. So the net ionic equation is going to leave this. So I'm just going to write, I'm just going to get rid of the spectator ions. Okay, so this is new stuff. This is stuff we did not do in first year chemistry. And definitely writing equations is something that we're going to do a lot in our class. Okay, let's go back and do one more, the last one. And like I said, I guess a couple little things to remember. What you dissociate are strong acid, strong base, soluble salt. If you have a weak base, then what it's going to do is it's going to accept an H, a weak base. If you have a strong base, it's going to give up OH, and you'll do the outers and the inners. So the last one, so here's going to be the molecular equation. So here again is here's a weak acid plus a weak base. Okay, so what's going to happen here is they're going to act the acetic acid again. So like I said, little things to watch for. What you're going to dissociate strong acid, strong base, soluble salt. If you have a strong base like the OH is down here in letter A and letter C, you're going to do the outers and the inners. But if you have a weak base like you do in B and D, that base is going to accept an H. So it's different. So this is going to accept an H. So we're going to have, again, this acting as an acid is going to give up an H. And so what's left over is that. Okay, so when it's a base, if it's got NaOH or KOH or CaOH2, one of those strong bases, you'll do outers and inners. But when it's a weak base, which is all the other bases, then they're just going to accept an H. So then in the complete ionic equation, what I dissociate here is really nothing, because this is a weak acid, so I'm not going to dissociate that. This is a weak base, I'm not going to dissociate that. And then I have two ions here. And since there's nothing to dissociate, this is going to be both the complete ionic and the net ionic equation. And again, I'm hoping you guys are watching these videos because we're definitely now getting into newer stuff, so you can look at that. Okay, and then the final thing, just to finish this slide. I think I screwed it up, but this is a good place to stop. So it'd be good to go back and to look at those problems. So guys, keep working on your AP Chem. Remember, your quiz for Chapter 3 is due Wednesday, Thursday, and I will see you guys. We'll do that lab. Bye.